Paper 3, October, November 2020, paper 32. Let's take a look at the first question. A fixed smooth solid sphere has a center O and radius A. A particle of mass m is projected downward with a speed of square root of 1 over 6 ag from the point A on the surface of the sphere, where OA makes an angle alpha with the upward vertical through O. The particle moves in part of a vertical circle on the surface of the sphere. It loses contact with the sphere at the point B, where OB makes an angle beta with the upward vertical through O. Given that cos alpha is equal to 2 over 3, find the value of cos beta. So over here, you can see that at this point, when it's a point B, where it makes an angle beta with the upward vertical, it starts to lose contact. Okay. So what we can do over here, again, this one, usually we start from the conservation of energy. We have the GPE loss is equal to the CAIE gain. So the formula will be mgh equal to the half m of the v square minus the u square. And you can have a v square equal to the u square plus 2gh. Your u is given over here. So it's a 1 over 6 ag. Your h will be a cos alpha minus a cos beta. But the question's given you that the cos alpha is equal to 2 or 3. So we can build a small right angle triangle here. This is a 2, this is a 3. From the Pythagoras theorem, we know that this will be square root of 9 over 4. That will be square root of 5. Okay, so it will be 1 over 6 ag minus a 2g. Cos alpha is 2 over 3. So you get the v square is equals to the 9 over 6 ag. This is a plus, sorry. This is a 9 over 6 ag. 9 over 6 is a 3 over 2. 9 over 6 is 3 over 2. So it's a 3 over 2 ag minus the 2 ag cos beta. Okay, so this is what we are having. Okay, so now what we need to do right now is to resolve the forces at B. At B, if you resolve the forces toward the center of the circle, you will get the mg cos beta minus the normal contact force is equals to the mv square over the A. Okay, so given R equal to 0, so you have a mg cos beta is equals to the m over A v square. So you have a v square equal to the GA cos beta. That is your equation 1 here. That is your equation 2 over here. Let them equal. Okay, so if you let them equal, then you will get this as the 1 equal to 2. 3 over 2 ag minus the 2 ag cos beta is equal to the GA cos beta. So if you simplify them, you can get the answer as GA cancel. So you have a 3 cos beta is equal to 3 over 2. So your cos beta is equal to half. So we are looking for cos beta. Okay, so the answer will be cos beta equal to half. If we are looking for beta, then the beta will be a 60 degree. So done. we have done the answer here. So this is the answer for the question number 1. Now we move on to the question number 2. A and B of equal radii have masses of 2m and m respectively. Sphere B is at rest on a smooth horizontal surface. Sphere A is moving on the surface with the speed u and collide with B immediately before the collision. The directions of motions of A makes an angle alpha with the line of center of the sphere, where tangent alpha is equal to 4/3. The coefficient of restitution between the sphere is 1/3. Find the speed of A after the collision. So for this question, usually I will write before and after over here. So before, the directions of A go like this. This is the alpha. Okay, this is a U. This is a 2m. Then before, the B is at rest. Okay. Then after, I will assume after it will move in such a way. This is called the VA. And the VB has to go this way. This is the 2m. This is the m. Okay. So now if we consider the one that is perpendicular to the collisions, we have something called the PCLM, Principle of Conservation of Linear Momentum. So we have the 2m VA 2m u cos alpha plus a 0 is equal to the 2m VA cos theta plus the VB, MVB. But I forgot that they mentioned that tangent alpha is equal to 4/3. So I will just need to build a small right angle triangle over here. 4 here, 3 here. Make the triangle smaller a little bit. 4 here, 3 here, then you will get a 5. Okay, so from here, you will cancel the m first. So you have a 2m, 2VA cos theta plus the VB is equal to the 2u of 3/5. Then you will get this as the 6/5u. That will be your equation number 1. And now we considering the NEL, Newton experimental law. This one will be the E equal to the negative of cos theta minus the VB divided by the U cos alpha minus a 0. So the E that are given in the question is 1/3. So you just write 1/3. So you get the VB minus the VA cos theta is equal to the 1/3u cos alpha. Cos alpha is a 3/5. So you have a VB minus a VA cos theta is equal to 1/5u. That is your second equations. We want to find the speed of A. So we just need to take the number 1 minus the number 2. You get the 3VA cos theta is equals to the, if you minus it, you get a U. So your VA cos theta is 1/3u. Then if you consider the one that is parallel to the directions of collisions, so over here you will have the U sine alpha, okay? If you consider this one, U sine alpha will be equal to the VA sine theta. So your VA sine theta will be the, from the triangle here, from this triangle, sine theta is, sine alpha is a 4/5. So it's a 4/5u. So therefore your VA square is equal to the VA sine theta square plus the VA cos theta square. It will be the same as the 4/5u square plus the 1/3u square. Just press a calculator, simplify them, then you can get your VA 13/5/15u. Okay, so if you simplify it, so this will be the answer for the question number 2. Now we move on to question number 3. An object consists of a uniform solid circular cone. Vertical height is 4r and the radius 3r, and a uniform solid cylinder of height 4r and the radius of 3r. The circular base of the cone and one of the circular faces of the cylinder are joined together so they coincide. The cone and the cylinder are made of the same material. Find the distance of the center or the mass of the object from the end of the cylinder that is not attached to the cone. So now over here they mentioned that they are made from the same material. So the diagram look like this. I just write down the cross sections only. So this is a 4r. This is the 4r. This is the 3r. It's also 3r. So the volume for the cone is 1/3 3r square, 1/3 pi 3r square h. Get 12 by r cube. The volume for the cylinder is a pi r square h is a 36 by r cube. Okay, so now we can build the table. So we have a solid, we have the cone, we have the cylinder, we have the combined object. Volume, this one is a cone is a 12 by r cube. This one is 36 by r cube. This one is a 48 pi r cube. The center of the mass from the base. So for the cone, it will be 4r plus 1/4 times 4r. It will be equal to the cylinder. It will be just 2r. So this one will be the bar y. You just write bar y here. Take the moment about the base of cylinder. So you will be having 12 by r cube multiply 5r plus the 36 by r cube multiply 2r is equal to the 48 by r cube bar y. All the by r cube can be cancelled. So you have a 60 plus 72. 60 plus 72. So your bar y is a 60r plus the 72r divided by the 48. So you can just press the calculator, you can get the answer as 11/5r. That is your bar y. So done for the part A. Now we move on to the part B. Show that the object can rest in equilibrium with the curved surface of the cone in contact with the horizontal surface. Okay. So over here, the cone is at rest. We say that the curved surface of the cone, this is the curved surface of the cone. Okay. So this is the curved surface. This is the This is the surface. This is the floor. Okay. So if your center is over here, then it will topple. Okay, because nothing to support. Nothing to support. So we need to show that the center of the mass is actually lies between the base, lie between the curved surface of the cone. Right? So if our G is over here, then at least it will touch with the center, will touch with the base of the touch with the curved surface of the cone. Okay. So this is what we need to show. Okay. So what should we do now? We need to write down. We need to show some alphabet over here. This is the, let me call this one O. Let me this one call A. Okay. So this one, let's say this one called O. This one called A. This one is a G. Okay. So we have a OA. What is OA? This is a 4R. This is a 3R. So OA is actually square root of the 4R square plus square is actually 5R. So what is your OG? Your center of the OG. G is the center of the mass. Okay, so G. So this is the theta. So OG cos theta is actually, what is OG? OG is the 8R minus the bar Y. And then cos theta. So cos theta, what is cos theta? So over here, because the theta that we have, this is a 4R, this is the theta, this is the 3R, this is the 5R. So the cos theta from here is actually 4 over 5. So from here, OG cos theta is 8R minus the bar Y. Just now the bar Y was 11 over 4. 11 over 4R. So your cos theta is a 4 over 5. So if you use your calculator, press it, you get 21 over 5R. Okay. So you compare your 21 over 5R is actually less than 5R, which means that the OG cos theta is less than the OA. Because of this reason, therefore, the object can rest in equilibrium. Okay, so therefore, I write the conclusion over here. Because of this reason, therefore, the object can rest in equilibrium with the curved surface of the cone in contact with the horizontal surface. Okay, I think we can just write the object can rest in equilibrium with the, okay, because of this reason, right? So you can see that your OG cos theta, this is your OA. This is your OA. So your OG cos theta at most, the OG cos theta at most can only be equal to the OA. Yeah, your OG cos theta at most is equal to OA, cannot be greater than OA. If greater than OA, then it will topple. So this is something you need to be aware of. So now we move on to the question number 4. A horizontal circle with the angular speed omega on the smooth inner surface of the hemispherical shell of radius r. The angle between the vertical and the normal reactions of the surface on P is theta. Show that the cos theta is equal to the G over the omega square R. So this is the diagram, the center. Okay, so you are having the P over here. This is the normal contact. R, this is your mg. And you're moving with the horizontal circle here. Okay, and you are making this theta. This is the particle peak. Okay, so what we can do now is if we resolve the forces vertically, you have a r cos theta is equal to the mg. If you resolve the forces horizontally, you get the r sine theta is equal to the mr omega square. This is the r. And your r over here is actually, oh, I cannot use this r because this r is the radius of circle. This is the radius r. This is the radius r. So over here, I need to use a different value of r. So from the triangle, you can see that this is the radius r1. This is the radius r. This is the theta. What is the r1? R1 is the r sine theta. R1 is r sine theta. So when I write this equation, this one's supposed to be r1. So it's supposed to be m r sine theta omega square. Cancel this. So you get r equals to the mr omega square. Okay. So I have this one as equation 1. I have this one as equation 2. Take the equation 1 divided by equation 2. You get r sine theta divided by r is equals to the mg divided by the mr omega square. Answer. Sorry, I write wrongly. This one, number 1 is r cos theta, not r sine theta. So cancel it, you get cos theta is equal to the g over the omega square r shown. That is the answer for the question number 4A. Now we move on to the number 4B. The plane of the circular motion is at a height x above the lowest point of the shell. When the angular speed is doubled, the plane of the motion is at a height of 4x above the lowest point of the shell. Okay, so for these two situations, okay, maybe we can draw the two situations up. Okay, so for the first situations, you are at here. This is the x. With the speed of omega. Okay, so when you are moving with a greater angular speed, you are somewhere here. This is the 4x, and the speed is double. The angular speed is double. So at here, I call this one theta. At here, the angle here, I call alpha. Okay? So your cos theta for this case, your cos theta, you need to refer to the triangle here. You refer to the triangle here, right angle triangle. What is your cos theta? Your cos theta is actually, this is the r minus the x divided by the r. And what about cos alpha over here? Cos alpha is this divided by the r. So cos alpha is the r minus the 4x divided by the r. Okay? So we already showed that the cos theta, can be presented in such a way. Part 1, part A. Okay, so part A, This will be a G over the omega square R is equal to the R minus X over R. So the R can cancel off. So you can get the R minus X is equal to the G over omega square. Then for this one, you just need to change your omega become 2, multiply 2, double of it. And you cancel the R, then you get the R minus a 4x is equal to the G over 4 square. So we're looking for X. We're looking for X. So I call this one equation 1. I call this one equation 2. So 1 into 2. So I get R minus 4x is equal to the 1 over 4 of R minus X. You get a 4R minus a 16x equals to the R minus X. At the end, you get 3R equal to the 15x. Then your X is equal to the 1 over 5R. Done. This will be the answer for the part B. So we're moving on. Question number 5. Point O on the horizontal plane and move freely under gravity. The horizontal displacement of P from O at the subsequent time t second are denoted by x meter and y meter respectively. Starting from the equations of trajectory from given in the list of formulae MF19, show that this equation is true. So what you need to do is just to search the formula booklet MF19 looking for trajectory equations. So you will have y equals to the x tangent theta minus a gx square over the 2u square cos square theta. Okay, so this one from formula booklet. Then change the cos square, make it become secant square. And the secant square, by using the trigonometric identity, we can change the secant square become 1 plus tangent square. Shown. Just like that. Done. Now we move on to the part B. When theta equal to the arctangent of 2, P passes through the point tan 16. Show that there is no value theta for which P can pass through the point with a coordinate of 18, 30. So what you can do is that from theta equal to the arctangent of 2, we will get tangent theta is equal to 2. So at the point tan 16, you just need to replace it inside here with the tangent theta equal to 2. So you have 16 equal to the tan tangent theta minus the g x square over the 2u square 1 plus 2 square. So if you press a calculator, you will get this one as the 2500 over u square is equal to 4. That will give you u square is equal to 635. And your u is 35 meter per second. So this is how you find the u. But after that, we need to use this value of u to substitute them inside to look for other value of theta. Okay, so at the point 1830, so your 30 is equal to the x tangent theta. Now this tangent theta can no longer be 2 because we're looking for other value of the other possible value of a theta. So this will remain as tangent theta minus a g x square over the 2u square and then 1 plus tangent square theta. Okay, so if you use your calculator to simplify them, you will get this one as 18 tangent theta minus the 324 over the 125. 1 plus tangent square theta. So if you rearrange them become a quadratic equations, You have the 324 tangent square theta minus the 2250 tangent theta plus the 4074. Okay, then you just need to check the discriminant. So because of the reason that the discriminant 2250 square minus the 4 of the 324 and 4074, this is equals to negative 217404, and is less than 0. Because of this discriminant less than 0, therefore, no real solutions. For data. Okay. So that's all. This is how you show that there's no value of data which P can pass through the point 1830. Now we move on to the question number 6. Length A and the modulus of elasticity K is attached to a particles P of the mass M. The other end of the string is attached to a fixed point Q. The particle P is projected vertically upward from Q when P is moving down upward at a distance of 4 over 3a directly above Q. It has a speed of square root of 2ga. This point, the acceleration is 7g over 3, moving downward. Show that k is equal to 4 mg and find in terms of a the greatest height above Q reached by P. So we have a point Q over here, and this point Q is fixed, and you attach to a string. So this string, the natural length is a, but when you extend to extra 1 over 3a, because the question mentioned 4 over 3a, so it will be total here will be 4 over 3a. Okay, so the extension is only 1 over 3a. Then your speed u is equal to the square root of 2ga. Okay, so at this point, your acceleration is going downward, and your tension is also going downward. So we are having the tension going down. So if I resolve the forces vertically, I have a negative T minus a mg is equal to the ma. So the negative T, by using the Hooke's law, it will be negative lambda x over a minus the mg equals to the m of a negative 7 over 3g. But we know that the lambda is k. Okay, and the extension, we know that the extension is 1 over 3a. So we can just change this to become negative k 1 over 3a a minus the mg plus the mg is equal to the negative 7 over 3 mg. So you cancel the negative. You have a 1 over 3a, 1 over 3 ka, 1 over 3 k. Is equals to the 4 over 3 mg. So therefore, k is equal to the 4 mg shown. So we have shown the first part. Find the greatest height of above Q reached by P. So the greatest height over here, that means we need to consider another case. Okay, so this is 1 over 3a. You need to reach to the greatest height. This is the x, we do not know. And when you reach the greatest height, your v is a 0. Over here, your u is still square root of 2ga. And your natural length is a. Okay, so we need to consider the distance from here to here. We need to consider this distance. So by using the conservations of energy, we have the, maybe I write it over here. So by using the conservations of energy, we have the EPE gain plus the GPE gain is equal to the KE loss. So EPE gain will be the lambda over 2a. The extension is x plus 1 over 3a squared minus the 1 over 3a squared plus the mgx is equal to the half m of the u square. Okay, so the lambda over here, we already found that the lambda is a 4mg. So we straight away write 4mg here. Okay, so this one, because when you reach to here is a 0, so it's actually just a u square, no v square. Okay, so just need to extend. So you have a 2mg over a x squared plus the 2 over 3ax plus the 1 over 9a squared minus the 1 over 9a squared plus the mgx is equals to the u squared, 2ga. So it will be mga. Cancel the mg. Okay, cancel the mg. Then you will get 2 over a x squared plus 2 over 3ax plus x is equal to a. So I multiply everyone by 3a. So multiply everyone by 3a, I will get 6ax squared. I get 6x squared plus the 4ax plus the 3ax plus the minus the 3a squared. So you have a 6x squared plus 7ax minus a 3a squared equal to 0. Factorize it. You have a 3x minus a, 2x plus 3a equal to 0. You have x equal to the 1 over 3a, and you have x equal to negative 3 over 2a. This negative value we should ignore. So therefore, our answer for extension is 1 over 3a. That will be the answer for the question number 6. Done. So now we move on to question number 7. Straight line against the resistive force of magnitude mkv square Newton, where v is a meter per second, is the speed of the after it has moved a distance of x meter, and k is a positive constant. The initial speed of p is u meter per second. Show that x equal to the 1 over k log 2 when the v is equal to half of the u. So what you need to do is that just need to resolve the forces horizontally. Since you only have a resistant force, so you have negative F is equal to the MA. So your frictional force or the resistive force is mkv square. You cancel the m, then you get A is equal to negative kv square. So we are looking for x. So our A will be v dv dx. So you just need to move it over here. Negative k dx integrate. So simplify it, you will get 1 over v dv is equal to the negative kx plus c. Integrate further, you will get ln modulus v is equal to negative kx plus c. So your modulus v is equal to the a e power negative kx. Okay. So we need to find out what is the c. So when x is equal to 0, your v is equal to u. So modulus u is equal to the a e power of 0. So your a is equal to the modulus u. So now let's proceed. Our modulus V is equal to the modulus U e power negative kx. Then when we take away this, we have two decisions. Either two choices. You're supposed to put plus minus U e power negative kx. Okay. So in order to fulfill the condition, in order to fulfill this condition, okay, your V must be equal to the U equal to the U equal to U multiplied by e power negative kx. Because of the x equal to 0, V is equal to U. Because of this reason. So now we are looking for x when the V is equal to half of the U. So you get half U is equal to the U e power negative kx. Cancel the U. So you get ln half is equal to negative kx. So your x is equal to negative 1 over k ln half. Okay. But the questions want you to prove that it's a positive 1 over k ln 2. So this one is just need to bring the negative up. Then you get 1 over k ln 2. Shown. So this is how you show the answer for the part A. Now we move on to the part B. Beginning at the instant where the speed of P is half U, we have additional force, X on P. The force has a magnitude of 5m over V, and X in the directions of increasing of X. Show that when the speed of P has increased to U meter per second, the total distance traveled by P is given by this formula, and state the value of the constant A and B. So now we have to recalculate again the forces over here. So we have a 5m over V minus the mkv square is equal to the ma. So the m cancel it. So our A is equal to the 5. We have a 5 minus kv cubed over V. Okay. So we are looking for the question is related to x as well. So our A should change it to become V dv dx. So you have a V square 5 minus kv cubed dv integrate dx. So this one, if you integrate, just use a formula of f prime over f. Just use this technique to integrate, then you can get the answer will be negative 1 over 3k ln modulus 5 minus kv cubed equal to the x plus d. Okay. So now they say that when your x is equal to the 1 over k ln 2, your v is equal to half u. So negative 1 over 3k ln 5 minus the 1 over 8 ku cubed is equal to the 1 over k ln 2 plus the d. So your d will be equal to the negative 1 over k ln 2 minus the 1 over 3k ln modulus of the 40 minus a ku cubed over 8. That is a d. And you replace the d inside here, things will be a little bit troublesome already. Have to be careful. So you get negative 1 over 3k ln modulus of 5 minus a kv cubed is equal to the x minus a 1 over k ln 2 minus a 1 over 3k ln 40 minus a ku cubed divided by 8. Okay. Then the questions are looking for when the v has become u again. So what will be the expressions of the distance travel? Okay. So when the V is equal to U, so you get negative 1 over 3k ln phi minus k u cubed is equal to x minus a 1 over k ln 2 minus a 1 over 3k ln of 40 minus a ku cubed over 8. So we just join together. X is equal to the 1 over k ln 2 plus the 1 over 3k ln modulus of 40 minus a ku cubed over 8 minus a 1 over 3k ln modulus of 5 minus ku cubed. We should multiply here by 3. So we can combine them together, become the 40 minus ku cubed over the 8 of 5 minus ku cubed. Then join together. This will be ln of this one. Oh, there's a ln here. I forgot to write down the ln. So this one, it will be ln of 8 multiplied by 40 minus the ku cubed divided by the 8 of 5 minus ku cubed. So 8 and 8 cancel. At the end, you get 1 over 3k ln of 40 minus the ku cubed divided by the 5 minus the ku cubed. Done. This will be the answer that you want to show. Okay, so the A is a 40 and the B is a 5. Okay, just like that, done. So this will be the answer for the question number 7, and that is all for this paper. So I'll stop the video here. I'll see you next time. Bye-bye.